Okay, so in this session we are going to delete element from an array, and there are three scenarios. First is deleting at the beginning, second is delete in the end, and delete at specific location. And we will also discuss algorithm of deleting an element from an array. So let's start from deleting at the beginning of an array. Let's say we are having this array which is already full, and we want to delete from this array. As you can see, there are 10 elements inside the array, and the indexing will start from 0 to 9. So the size of the array, to store that value, we are going to use a variable and which is equal to 10. But a10 doesn't mean it doesn't actually exist the value, because the indexing will start from 0, so the last index value will be 9. So the last element will be at the a and minus 1, which is a9. So let's say we want to delete the element at the position number 1. Position 1 means that we are talking about this, and if we're saying that index number 1, so we are going to talk about this. So this at the position number 1 means they are talking about position minus 1, which is equal to first index, which is 0. Okay, so let's say I want to delete this value right at the beginning. So what we will do is, as you can see, we just cannot delete this value directly. What we need to do is, what we can do is simply just move the values from backward to the forward. So what we are going to do is, we just access the index number for the last element, which is n minus 1, and here the value here for this particular value is I is equal to position minus 1. So for this particular value, I is equal to pos minus 1, which is 0. So there are two values for the last element and for the first element. All the operation will be performed here. So we are going to start from here. So here we are going to just simply uh, access the value from here, and we are going to copy here. So what does it mean? We are going to start from this position because we want to remove this value. So we start operation from here, but we are going to access value from here. So we need to increment the value, right? So in the insertion we decremented the values, or you can say the indexes, but here we need to increment the values because we are going to start from here. So what we can do is simply just perform the operation on 0th index, which is position minus 1. So position is first, so position minus 1 is the 0. So operation is performed here, but we are accessing value from this, which is accessed by just simply incrementing I by 1. So simply copy this value. So now 3 is not existing, right? So we just remove that value. That value is simply lost, and we wanted to lose that value, right? So now we will start incrementing the value, and next operation will be on the first index, and we will access this value, and we are going to copy this value here, and we will do the same for the index number 2, then 3, then 4, then 5, then 6, then 7, then 8. So finally we just stop here for before the last element, because we just can't access any value here, so there is no value after that. So we just access this value and perform the operation on index number 8. So if we need to write the code will be, first we initialize the I with the 0th position, or you can say the 0th index, the position is 1. So we will write I is equal to position minus 1. So here we start, the position is 1, but we are writing I is equal to position minus 1, means the indexing will start from 0. Okay, so for the 0th value, first the value is initialized, then we will check the condition. The condition is saying n minus 1, n minus 1 is 9, right? The last is index. So this condition will be used, and initially the value is 0. 0 is less than 9, yes, which is true. So this part will be executed, and this part is saying the 0th index will be assigned a new value from the previous index. So here the value is assigned from the previous index, right? So a of 0 will be having the value from the a of 1, and whatever was at the beginning, is completely lost, so we wanted to delete that value, so that value is deleted. And then as we must set this, right, so we'll keep on incrementing the value. So next step is just incrementation, and after incrementation it is going to check the condition again. So after incrementation the value of I is equal to 1, so I is less than 9, which is true, so this particular value will be copied for the 2 3 4 5 6 7 8. So I perform the operation till 8. So for I is equal to 8, this particular value from the 9 is copied inside the 8. So A is assigned the value from the ninth index. And then when the value is 9, so here the I is having the value 9 and n minus 1 is also having the value 9. So the condition will fail because I have write less than, there is no equal sign, so this is going to be false and it will stop, the for loop will stop, and finally the value is deleted already. So if it say this value is still there, so this is just a garbage value, you can store a new value here, it will stay the same. Okay, so this is the worst case because I had to delete the first index value and I had to shift all the values from the backward to the forward. So this is the worst case and the complexity is of n. Again you can say the for loop there is the complexity of n. So let's say we want to delete the value from end of the array. So this is the array and these are the indexing, and the size of the array n is having value 10, or a last element is at n minus 1, which is a9, right? So let's say I want to delete the value at the last index number. So last index number will be at n minus 1. So I will have to delete this value. I simply, what I can do is I just shift the pointer, which means n is pointing to n minus 1, right, which is n is equal to 9. So I will simply shift this pointer to here, means I will to here, pointer is actually here. If I say the last element is at this index number, I will simply change the index number here. So n is equal to n minus 1 means this is the last value. So n is equal to 9 is pointing to the a9. So I will simply write last element is at n minus 1, which means we will just decrement the value of n is equal to n minus 1, right? So n minus 1 is at a of 8 now, so I will just simply decrement this value by 1 again, and which will be having the value a8. So simply switching the position of the last pointer will simply remove this value. This value will still exist, but this will be the garbage value. The pointer is here now for the last element, right? So this is the best case, right? So what if I want to delete a specific position? In that case, we are going to see, take the same example, right? So the position, let's say position is given 6 means the index number 5, right? So 5 is here, but the index number or you can say the position is 6, right? So the value is 11, which I want to delete. The last element is at a and minus 1, and here the position is I is equal to pos minus 1, so the position is 6, so pos minus 1 means 5. So I initialized I by 5 because I want the iteration in between these values, right? So if I increment the value, it will access this value, right? So what I'm going to do is I will simply access this value and store it here, right? So this value will automatically be lost, right? So the operation is performed here, but we are accessing value from this index number, so this value is copied here, so 11 is no more. And now I must switch all the values, so we are going to keep on incrementing the value and we'll perform the operation on a6 and then a7 and then a8, and finally we are done because we need not to perform no, from a8, yeah, perform operation on A8, but need not to perform operation on this, because now this is the garbage value, the actual values are here, right? So we need to write the code. So I will be having the values pose -1, and the condition will be n minus 1. So the value here is 9 and I is having value 5. So position was 6, but the value will start from 5, right? Pose -1, which is 5. So for 5, from the 5th index, the operation started to perform. We access the value from the 6th and store the value into the 5. So here also we are accessing the value from the 6 and storing the value into the 5, and then we keep on incrementing till I is equal to 8. So I is equal to 8 here, and we access the value from here. And when the value is 9, it will be false, because here also 9 we have not write uh, equal to sign, so the value is 8 here, sorry, 9 here, and here also. And for that, this operation will not be performed and it will simply come out. And here we are just shifting the pointer as we did in the previous slide. We will write n is equal to n minus 1. So the pointer was here, now we are going to shift the pointer here because the last value is here, right? And this is the average case, because the position can be the second position, third position, because in that case we just need to skip the first position only. So here also the complexity is of n, also the for loop is having the complexity of n. Okay, so let's see the algorithm for the same. If the position is 1, it means you have to delete at the beginning. The position is n minus 1, means we are talking about the end of the array. And if there is any position j can be anything. Let's say we are having the 6th value, then we are talking about the 6 minus 1 index number. The index is 5 here. So first is you have to initialize here with the position -1, not n minus 1. Here position -1 means we are going to start from the actual index number, and we are going to use this condition for 9. For our example, the n minus 1 was 9, and it should be, I should have the value greater than this 9, right? Okay, it should be less than, right? I don't know, you can check the previous slide. Okay, so we are simply going to access the value from the next index, and we are going to store the value to the current index, and this will keep on doing. And again we are going to increment the values. These two operations will keep on doing till the condition is true, and when it is false it will come out. And we are going to simply increment the index number n is equal to n minus 1, so that we know that the last element is at different index number, right? And finally we exit.